Welcome back, chemistry fans. Today, what we are going to do is finish up the free response questions from your Unit 10 exam. Let's jump into it, get started, and we will show you how to make corrections if you needed them. So here we go. Here's the first one. This is the toughest questions on the test. These are where you have to show that you understand what the reactions are and how to balance them. Now, on your test, I'm going to have on here octane's formula. That is C8H18. It's completely combusted in air, meaning that it has oxygen in it. So what it makes always is carbon dioxide and water. That's the part of a combustion. So now balancing it, though, that's a little bit more tricky. So I got 8 here. I got 9 here, but that's going to cause things to be imbalanced. I got 9 because of the hydrogens. We needed 18 hydrogens. Well, now what I've got is 16 and 9. That's equal to 25. That means that this would have to be 12.5. It's now balanced, but we need to make sure that there's no decimals in our coefficient. So everything gets multiplied by 2. So my final answer ends up being 2, 25, 16, and 18. Those are your correct coefficients for A. All right, B, solid barium iodide. So here's where it gets tough. You have to rely back on your old skills of how to balance charges. It's decomposed when it's heated, so it's going to make barium and iodine. It's done. It's that simple. That one was not so bad. All right, part C. Lithium is added to sodium bromide. What's going to happen is the metals are going to trade places because this is a single replacement. And so you're going to end up with sodium by itself and lithium bromide over here. And then the final step, D, aqueous copper sulfate, CuSO4, the charges are balanced, is added to aqueous ammonium hydroxide. It's also balanced, +1, -1. So what's it going to make? It's going to make copper hydroxide, and it's going to make ammonium sulfate. Now, these are not balanced, though, because this is a +2, this is a -1, it needs to have a 2 here. Because this is a +1 and this is a -2, it needs to have parentheses and a 2 right there. So now it is all balanced. The reaction is balanced. However, I've got to balance the compounds are balanced. The reaction is not. So I got to put 2 in front of the ammoniums, and that takes care of also the hydroxides, giving it both balanced. All right, that is question number 11. Hardest one on the test, probably. Now, question 12 gets into some of the stoichiometry. So here we go. You're given 14.4 liters of CO2. How many grams of this are there? So I've got to set up a ratio. 14.4 over 3 times 22.4, because it's in liters, equals X over 2. Now I got to add up my weight here. 39 for the 2 potassiums each, 1 for the carbon, and 3 of the oxygens at 16. So that is a total of 48 plus 12 plus 39 plus 39, and that gives me 138 as my total here. All right, now I'm going to cross multiply and solve for that X. 14.4 times 2 times 138 divided by 3 divided by 22.4, and you get 59.1. 59.1 what? Grams of K2CO3. All right. So let's get started on question number 13. Number 13. On this one, we are given atoms of K. So I've got 3.46 times 10 to the 22nd atoms, and you're given 0.75 moles of CO2. What we're looking for is grams over here. So which is the limiting reactant? So we're going to have to do both of them. So I got 0.75 over 3 equals X over 2 times, we already added up this weight. 139, was it? I can't remember. 48 plus 12 plus 39 plus 39, 138. And then we'll do a second one. We'll do the 3.46 times 10 to the 22nd over 4 times 6.02 times 10 to the 23rd equals the same amount over on the right, 138. They are both going to solve to the same, but we have to figure out which one is the actual answer because it's a limiting reactant. All right, so let's crisscross applesauce. 0.75 times 2 times 138 divided by 3, and I get 69 grams here. Let's try the other one. 3.46 to the 22nd divided by 4 divided by 6.02 to the 23rd times 2 times 138 gives me 3.96. You could round that probably up to 4 grams. So that would be my answer for this question number 13. I got one more to go, and this is a percent yield problem. So in this problem, again, you're given 2 starting points. Oh, no, you're not. You're just giving 1 starting point. It gives you 9.9 grams. We're looking for this. So we're going to do a percent yield. So 9.9 grams. Now I've got to go and add up my weights. 207 for lead, nitrogen 14, and the oxygens are each 16. But there are 3 of them, so that's a total of 48 for each one of those. I will have on here the weights of these elements so you won't have to look them up. 207 plus 28 plus 48 plus 48, and that gives you 331 is the weight here. And we need to add up the weight here, 207 plus 16. That's 223. So 331 goes here. X over 2 times 223 goes here. We cross multiply 9.9 times 2 times 223 divided by 2 divided by 231, and you end up with 9.56 grams. But that's not what it's supposed that's what it's supposed to. This is my stoichiometry value. So now percent yield is a formula where you're going to do the lab value divided by the stoic value. So we just calculated the stoic value as 9.56. The laboratory value was only 5.5. All right, so I'm going to do 5.5 divided by 9.56, and I get 0.57, which you multiply by 100%, and you get 57.5% or somewhere close to that. All right, thank you very much for your time. Thank you very much for paying attention. I will hopefully help you out individually. If you need it, come and see me, and this will hopefully help you understand your content a little bit better, see where you made some of your mistakes. Talk to you soon. Farewell. Bye-bye.